Alright, hello everyone, and welcome to today's live stream, where I'm just going to be playing around with some shader magic, some ray marching, some recursive subdivision later on. But I just want to show this little setup that I have right here, and actually I need to get rid of most of the nodes that are completely unnecessary in this case. But yes, I was playing around with fractals, as one does quite often. And I was like, you know what, let me just go and see what I can do with the iridescence, because that always leads to very, very cool results. But yes, so let me get rid of all the unnecessary nodes so that I do not overwhelm you with information. Let's see, yeah, that should be okay. The gist of this setup is that I am ray marching a fractal. In this case, this is the node setup for that. You know, pretty simple. The distance estimator is, close to accurate, but what I do is I take each step of the ray marching and basically do this. I take each step, the distance and the old distance, I subtract them, set it to be a power of 2, map range, yada yada yada, all this fun stuff, and basically turn it into a color. So each pass, this color value gets updated and added during the loop. So if I were to turn down the ray marching steps, we can see that the amount of colors goes down. The more of these I have, the more colors go on. Basically, each ray marching step is colored. That's the gist of it all. And it is interesting. Like you can see I have the time affecting everything there. Funnily enough, multiple times I tried adding in the scene time node because I kept thinking I was in geometry nodes, seeing the repeat zone. But nope, we are in the shader editor. We get full advantage of GPU acceleration, which is nice, which is quite nice. Hello to everyone in chat. But yep, as we can see, that's pretty simple, pretty standard. This won't be the main thing for this stream, but I just want to showcase it in case anyone wants to take a crack at it. Again, here's the fractal setup. Here's the ray marching setup, which is a little bit more complicated than I would have liked. But yeah, you can just see the old distance, the iterations and all that. And then inside, this is just the color adder and all that with a little bit of decay over time. If I turn up the decay, we can see that something like this happens, which is intriguing, interesting, fascinating. Let me actually go and play around with this a little bit more. So in this case, let's just have ooh, that's cool. Also, because this is ray marched, I can place the camera wherever I want. So let me just go and delete the movement driver and start moving the camera. As we can see, the distance estimator is a bit warped to get the cool iridescent effect. As we can see, it's working quite well. Let me go and change the camera FOV. There we go. So we can see the entire area. But there's more I would like to show with this. So let's go to a new file. I know I just briefly glanced that setup, but, you know, I want to get to the main course for today. So here we are at part 2. So this is ray marching again, but a unique pattern emerges when you just ray march from the center. Let me go and collect the camera again and move it around. We can see that we're just inside a gigantic grid of spheres. Which, let me actually go and disable, well, yeah, let me go and mute the subtract. That is not how it should occur. Oh no, it is how it should occur, right. So here we just have a ton of spheres, and we can see that they're just in a grid, but when we go and change the parameters, we get some very interesting results. Like, look at that. That is very cool. So many of these feel like phone backgrounds, tech backgrounds, like pretty cool stuff. But keeping the camera at basically 0, 0, let's set that to be 90 degrees, all that to be zeroed out, we just get to see, yeah, cool backgrounds. Again, just the ray marching step. If you're wondering why I'm passing the position and direction through here, when I could just pass them in through there, it is a bit faster just to put them through here, because for some reason, I think the socket referencing slows it down a bit. So just keep that in mind. Again, the SDF here, that's the old fractal one that I was testing. Here, it is literally just wrapping the world getting the sphere distance. Again, if we do this, we can clearly see, oh, let me go and turn off that. You can clearly see all the spheres just laid out in this very intriguing grid pattern. So that is quite cool. But I want to try something else today, which is, well, we can stay here for a little bit longer, I think. So what if we were to square root this? I could try the fractal space again, but I'm kind of liking... Actually, let's try that out. I haven't fully explored the dimensions of this. Although, let me also go and subtract... Or no, let's use a mix node. If the SDF is within, let's say, 50 units, the distance will be 1,000, which means that there will be nothing in front of the... No, less than. There will be nothing in front of the camera, and it is broken. I would like to say that I expected that, but no, I did not. Let's go and move the camera around. Oh, there's no... the plane in front of the camera. Let me go and move that. Odd. Alright, well, let's just go back to the basics. Just look around in space. Oh, that... The bitrate is probably absolutely loving this. So let me try to make it a more cohesive pattern. Look at that. Love to see it. I guess this is just an extreme form of the Moray effect, I believe? Yeah, look at that. So cool. Here we go. Alright. Let's see now. So for today, I want to do 3-dimensional recursive subdivision. Hey, are you quiet on my end? Oh no, No, the audio should be fine. Let me just go and check it real quick. Give me 1 second, everyone. Nope, all the mic stuff should be fine. Yeah, it might just be on your end. On OBS, all the audio levels seem to be okay. But yes, well, that's good. How long does it take to master this? I would say a while. Because in this case, I mostly, like, with this part, I'm just following on intuition and then just looking at the cool results. I'm just literally playing around with the toy. But when it comes to stuff like the fractals, you have to follow a recipe, because if you want to create your own original fractals, while it is possible, and I have done it, you won't get the, like, amazing results. So, if you want to follow a recipe, you know, that's pretty straightforward, but it may take a while. And it should be noted, for those of you who are fairly new to Blender, I am using Blender 5.0 beta, because the repeat zones are not in any previous versions of Blender if you ignore the NPR branch. But yes. So, let's get to today's thing. 3D Recursive Subdivision. So let me just go and save this project as a duplicate. Because I keep forgetting to do that pre-stream. Alright. So, the idea is that with the SDF in here, which we do not need that or that, keeping the loop part there is fine. Again, this just speeds... Let's keep it simple. We don't need all that. Yeah, no, let's just... Even though it will be a little bit slower, if you have, like, more trees doing stuff, it would be completely fine. Just do that and that, so that we only send the distance through here. Apparently this is the correct way to do ray marching. I know in the past I would just loop the position through there, which in theory is not the worst. But I assume it just, since you're storing one float, it's a bit more efficient. Maybe not faster. Let's set this to be 100 iterations. Now we should see that I potentially have broken it again. Let's see, just the SDF is going through there, being passed through there. Yep, that is fine, that is fine. Ah, that's the problem. Here we should see, yes, the position in space. So that's good. the ray marching is working as intended. Let me go and delete everything else. If I were to just warp the position, it would eliminate quite a few nodes. I'm going to make a duplicate of the ray march setup and do that, just so that we have the simplest version of this. So in this case, I will pass the position through here. Again, the proper way that I've seen people do this is just to add to the distance and then offset it, but doing it this way, it's not bad. Actually, I could just go and do this and make it even more. Yes, less nodes to fuddle? Is that a word? Just that, and we plug in the SDF into there. And eliminate the loop. Yes, I know what I'm doing. Okay, so in theory, that should work. Then we only pass out a position as well. So in this case, yeah, it's fewer nodes on the inside and outside, so I'm gonna stick with that. The result is it should be the same, right? Take normal and you do that. Actually, I can test this because I have you and you right here. So we get the incoming, which is the right direction, and then we get the position, which is just the position. I don't know why I put that down there. Then again, with the distance, we go and scale that. We normalize you, and then we go and scale you, and then add that to you. Okay. I just want to do, before we get to the meat of today's episode, I just want to double check that we're getting the same result from both of these. Yes, we are. It is indistinguishable. Good. Actually, wait, I need to keep you around, just in case I want to switch back. Okay, so that's how that's done. Let's go and eliminate the add node, because we're just going to be moving our camera around. And the incoming is set to -1. Uh-oh. Oh, it's not connected. Of course, that would explain a lot. Yes, we have all of that, and we're just moving around. Let me go and get the camera back to almost 0, 0. There we go. So now, let's start our 3D recursive subdivision. So we'll be following what I did previously, and I think in this case we will, yeah, let's go and move these two up here, disconnect them for now, because we do not need them. The plan is to take 3D space, and then subdivide the first part, and hopefully I can correct the SDF to make it work. So, let me check the chat again. Is this how the game devs make Starry Skies in open world games? No, that is just a texture. Or if they're really ambitious, multiple textures. Let's see. Yeah, I'm not deep into nodes, but everyone is talking about repeat zones and shaders. Yes, apologies if you heard a loud car in the distance. The timing is impeccable. But yes, let me just get a cube. I need to just get a cube SDF going. So I need to subtract 0.5, absolute AB, and then separate XYZ. This is just to get a smooth cube SDF using a smooth maximum, if I'm correct. I keep forgetting which one to go with. We connect all of these around, and then we set a value node. Oh, also I need to check if OBS is picking up my microphone correctly, because there was some weird audio. Okay, no, it is going. Okay, good. I just remembered that some things went wacko mode yesterday with my audio settings, which is a curse of mine. It always happens. So let's put that into a nice frame. I love the new frame hotkey. It is so nice. Infinite thanks to the devs for that. Bring this over to here and this over to here. So we should see, as, yep, exactly as planned. I am not moving the camera anymore, which is a mistake. Let's keep the cube here, which is fine, but let's go and select the plane. Okay, so here we can just look around and that is working well. I do not know why we are seeing the void back there. Oh, wait a minute. I know why we're seeing the void. It's because of, yeah, the setup that I had. Okay. Not actually. Yeah, no, that makes sense, because that's into infinity. Because if I were to lower that, we can see, yep, that it is working as intended. We're just seeing into infinity. Let me go and normalize this instead, so that we do not see into basically infinite. Wait, why is normalize doing that to it? That is intriguing. I guess I always could throw on a max, or wait, there's the clamp node. So that I can always limit this so that its max distance will be like 100,000 or whatever. Yeah, let's do 5. We don't need too many iterations. Let's do 50. Okay, so now we got this, and now what I want to do is split up the world space. So this will be smooth cube. There we go. I need to stop capitalizing the frames. Let's see. Let's read the chat again. It's like chopping a cube recursive subdivision style. Yes. Well, the cube is just to show the UV space so that I can chop it up and all that. Let's see. So now let's go, if I remember correctly, how to recursively subdivide one axis of 3D space, and then I can randomize which one happens, and also I need a repeat zone for that. But let's just start extremely simply. So I know I'll need to use a math node, set this to divide. We'll do that. And if I remember correctly, it'll just be divide by a fraction. No, multiply. Oh yeah, that will work. Okay. So we just get a value, we divide by that, and then if the value is greater than 1, we switch between an inverse version of this. Divide, yes. Actually, let's do this to the z, because that is at the bottom of the thing. So we need to do this again and then mix between the two results, but we need to do 2, 1 minus. Is not there. Come on, buddy. Subtract. There we go. So that one, and then we need another 1 minus into here for that value. Or yeah, I could just put you down there. It should work just fine. So that and that. So in theory, it should work well. We go and throw in a reroute. I love nodes. They are very easy to organize. They're fine. Like, they're... In the nodes versus code debate, code is always just better to organize because, you know, it's just lines of text. But nodes aren't that bad. Here we go. So if we do that and that, in theory, this should split up the space. But we can also see that it is negatively warping the... Let me make sure it's then... No, okay. Maybe I need to check this out in 2D space, even though that would suck. We're doing all that. The SCF is... Yeah. Yeah, no, in theory that should be working. Again, divide by 0.5, so it should split it in half. And with this, I can multiply each side's position, or the distance by that, and that maybe should work. Let me test this in 2-dimensional space before I get too cocky with trying to put it in 3D. So, new, let's go and use the geometry position. Then let's go and add in our SDF. And do a nice little cross-section check. I think it's actually working. Let's go and delete all the other faces, scale by 2. I'm still not sure if this will work or not. Yeah, no, that does seem to be working as intended. Let's also output the UV map so that I can see what's going on with that part. Oh. Wait a minute. Oh, yeah, no, that's a problem. No wonder it was glitching out. So yes, it is working as intended now. I just screwed up the parts there. But we can see that the distance estimator is getting, let's putting it lightly, very, very, very screwed up. Which is not great. But we don't necessarily have to remarch this result. Not necessarily. But Now is the part that I don't really want to do, which is switching. Which axis this is being operated on. Now, I could just use a shuffler, but I want an index to shuffle them around. Because it would have to be mixed between X, Y, and Z, and then undoing that afterwards, which would be so annoying if I can't do it in a timely fashion. What would be the best way of flipping around the axes? I could always cross product once or twice, and then undo the cross product. Honestly, wait a minute, that might be the best option. Would that be the best option? Wait a minute. Let me try this. Cross product 1 and then a -1 in post. But no, any way I slice it. Any way I slice it, I would have to do that. No, that might be a bad idea. Let's go and check this. Which axis is the splitting happening? No, that doesn't appear to be oh wait, no, it's not actually connected to that. It is working. In theory, once more. No, I'm spinning around the z-axis. That would not work. Let's have that, and let's have that. Or nah, I think just a regular switcher node group would be sufficient. And yeah, we can see, yep, that is working. Okay. So this part should be isolated. Or wait a minute. I could just have a node group with all these and then I just switch which one is on or off. I think that might be the best option. But I would need a node group. Okay, well, dang, as much as I hate to say it, the mixed node would make it so that the other parts wouldn't compile. So I could literally just make it so that we have duplicates here, and no. Sorry that I'm so hesitant to do this. Okay, yeah, no, let's just do it this way. Okay, node make group. We'll just do this and then have a factor for if it is on or off, use mix node. And if it is not on, it should not compile. Or have to cause a recompilation. Or, I do not know. There's probably a better way of doing it, but... Factor... Yes. Okay, let me just check this. 1. No, not there, buddy. No, it's not deleting. Please tell me it's not. Okay, it did not change the internals. That is fine. We need to have that as the second input. So now I can just turn it on or off. Let me make sure that the factor actually shows up as this. We are at 23 minutes. Not the worst timing, including the intro. But it could be faster. Now we'll still need a random value. Oh no, this is going to be so much worse than anticipated. Yeah, no, I can't do that. Because I'll need to output a random value along with this, and I can't do that reliably if I'm just switching these on and off. Okay, nope. Can't do that either. We are debugging and just finding a good way to do this alive. So let's go and move this over to here and that over to there. Control X, that out of here. Yeah, no, that was not a good idea. Because I think, no, that's not the way to do it. Alright, well, we're just gonna do it the ugly way. By just having mix nodes between all the axes. And that, wait, do we have the index switch node? No, we do not. Menu switch? No. Then I'll need a value node and then a subtract. Basically make this an index switch, where one will make it so that it's the y-axis, the other one will do that. Then I basically need to have an inverse of this where it'll decide whether to go to the x, y, or z axes. Which is so annoying. I could still do the cross product. Let's do the cross product. Is there a reason for not streaming over 1 hour? It's because my brain starts to deteriorate after 1 hour. Common problem with people who do math. We cannot exist after that time. So here, I can just mix between... Yeah, no, I can just have one value, then just invert it, and then plug it into there. Yeah. Then just have a mix node to decide between axis 1, 2, and 3. Set that to be a negative. But yeah, after talking for an hour, it just becomes harder to do stuff. I usually don't talk while working, so it is, yeah, wait, what was I doing again? Mix... Right, we were doing that, but how do I set it up so that... That would be 1, 2, or 3. Man, why is this hurting my brain so much? I am, well, this is classic for me, but sleep deprived. Could do that, that. Nope, that does not change anything. Alright, I guess we're just doing the combine XYZ with a mix node. As the... Wait. Am I missing something big, like how to switch between X, Y, or Z with an index easily? Or no, I would only have to switch between X, Y, and 0. So 0 would equal nothing happening. Cross product would just not occur, in theory. 1 would switch it from Y to... Z to Y, and the other one would be Z to X. So it would have to be, if the value is equal, compare, equal to 1, or at least in the range of 1, it'll be on that, and if it is 1.5, so within the range of 2, it'll be that. So in theory, and the ellipson will potentially be an issue. So if it's 0, nothing should occur. If it's 1, it should do that. If it's 2, it should be that. Although it looks as if I remember to connect it to the output there. These outputs are not going to the same destination, so let me go and connect that there. So in theory, this should only change... Oh no. It is actually rotating the setup. It should be a negative cross product, so it should just undo what is done. Eesh. And does that just completely remove the, thing? 90, RY, 90. Wait, let me just check this. So, oh no, 0 just kind of eliminates it. Well, that sucks. And on there, it'll be that. Yeah, no, that just kind of sucks. Man, why did I think that just the axis switcher would be the most annoying part of this? And we're back to square one again. Okay. Sorry for the delay, everyone. My brain is just calculating slowly. So, we'll start out with x. So, if this is 0, or anything less than 0, Wait, no. Value should be 1 and 2, and then the ellipson should be 0.5. Yeah, no, okay. So if it's 0, it'll switch to the x-axis. If it's 1, it'll be y, and then if it's 2, it'll be z. Okay, yep, no, I get it now. Then we can split these up and do that. Okay. Why was that the most annoying part? My god. Okay. And then we just need... There we go. Now we just need to have an axis input switcher. So we just need a mix here, and then a mix here. Where the top input is the normal one. Let's not forget to connect that there. That one, that one, that one. That one, that one, and that one. So, and then we just need to connect that there, connect that there, and then if you're equal to 0, you will be this one. Even though that should just... Actually, no, we need all the states stated. This is nice. This is... not great. Yeah, not great in terms of spaghetti. But it should work. Should be z-axis in that case, x-axis, y, and z. That invert z value. No, it did not. Okay, good. So that is now working, even though it is so annoying to look at. I could just combine XYZ and then separate XYZ to make it one thing. Actually, yeah, let's go and do that for less node spaghetti. Combine X, Y, and Z. It's kind of like a bundle node, which I could use, but that would be overkill in this instance. And also, I just remembered that we have the vector mix on the non-uniform mode, or the non-uniform mode, which means I can just straight up connect this to here, and this into there, and then eliminate all of that. Huh. How about that? I know that into there, and then you into there. I knew I was going in the right direction. Okay, that's not as bad, but we still, I think, need to separate those parts. So, not the worst, but far from the best. So again, let's go and check this. Yep, that works. Okay, not bad. I'm just remembering what GeoNode or shader nodes are capable of. And I think that is the best version of the switcher. Unless... Wait a minute. I could multiply... Wait. This is probably a bad idea. I could just multiply the axes and then go and separate color value. No, I think that was a bad idea. Yeah, no, that clamps. Okay. Unless I'm missing something, or I could take the length of the vector. Oh yeah, no. Vector math multiply, do that. Hopefully they just don't overlap. Get the length. Or the dot. Once again, I forgot that dot product exists. I am dumb. There we go. So now we've eliminated... I think my gut knew that dot product was the thing because I went for cross product. Oh, that is extremely annoying. But I got there in the end. Okay, so we just take the dot product, which is basically the distance along axis node. That's just what my brain says it is. And then we have that. So there we go. We now have that. It works. It's good. and now we need to use a repeat zone for the repeated subdivision. Let me just go and put a nice little reroute there and there, or that. Okay, now with that out of the way, we can do this again and again, but then we will need to plug in a changing value for that. So, oh, wipe the, chop that out, put you there and there, and that into there. So we should see, as we go and subdivide this, subdivisions are occurring, and occurring quite well. Let's use a greater than to go and show this. That is probably an issue that I'm going to ignore. Let me go and undo that. Yeah, no, we have that and that. Is there something that's clamping? Oh, that's because that's set to 0.5 if we set it to be 0.1. Oh, right, of course. And then we have that going. So let me just go and eliminate that part because that was not a good idea. There we go. So now we can clearly see. Sorry that this is taking so long. Just that axis thing. I had it in my gut, but I did not properly execute it. Here we can see that the recursive subdivision is indeed doing its job. Now, depending on the iterations, we need to go and plug that into there. And then randomize it depending on each thing. So I'm going to use a wrap node and set it to be between -1, which despite... I think that should work. Should be getting... Even though I'm setting it to be -1, from what I've experimented with, that usually hits 0 when it wraps around X, Y, Z. Alright, that is working. And also, just for peace of mind, I really should have subtracted the position by 0.5 before putting it into there, so that this will be completely add 0.5. That'll be middled out, but no, that doesn't work because the cross sections are no longer doing that. Maybe I should just plug this into the volume output. Wait, what? Oh, right, because of that. Let's go and put in a volume and do that, and no. Oh, no, that needs to be less than. Less than. There we go. Now I can see our cube. So I don't even need to use ray marching in this case. I could just use straight up volume. But I do want to ray march it because that'll look cooler. Okay, now that we have that, we have this part switching between the axes. Now it's not random as I want, but it is okay. We can see that it's doing that. Then the more we subdivide, the more that happens, which is cool. But now we need to go and actually add in that random per segment thing. So if I remember correctly how to do this, I need to use the greater than and have this be our random, or our iterating random value, which I believe I need to take the previous result, multiply it by 2, or no, add this part right here, multiply it by 2 so that we can get a unique hash for every value. So let's put this into a white noise texture. Just needs to be one dimension. Then we feed you into the output, and in theory, if I go and vector math multiply so that we can get the color in here and actually connect it to the output, we should see that we're getting completely random colors that have no pattern to them whatsoever. That looks promising. Okay, that looks like it works. So this is our random seed value. Let's go over to here and switch this to be an integer. Or no, let's keep it as a float to avoid any weird conversions. So that is our seed value. Now we can go and plug this into a noise texture, white noise texture, whatever we want. I still want the switching here to just be 1, 2, 3, or 4. I dislike having to use the compare node for this. But now I can go and put the seed value into a noise texture, 1 dimension of course. Use an add node, plug this into here. Set the scale to be like that, and that should be fine. I should multiply the seed value by a lot. Not too much though, because float point precision issues haunt me at every turn in my work. So if we do this, we should see, yes, it is working. But we're starting to see an issue, and the issue is lag. This can be extremely, extremely slow. But it is working. We are at 18 subdivisions. This is an animated value. Also, yeah, no, the detail's like that. So if I turn up the detail, it gets way worse. Okay. These volumes are ray-marched anyway, but I want this to be almost a flat surface. But that would make it so that the distance estimator would have to be accurate. And if you're wondering, wait, why not just do this in GeoNodes? It's because I've already done this in GeoNodes. But in the shader editor, we can get away with some really cool stuff. So let's get the scene time node. Scene. We don't have the scene time node in the shader editor. I keep forgetting. I'm in the shader editor, not the GeoNode editor. So we need to use #frame, which is slow. But here we can see, I'm not liking the pattern we're getting there. Let's go and do that. Let's go and turn up the subdivisions even more. So that's cool, but could be better. Could be a lot better. We have that, and we have that. So we have our SDF, our UV value, and then our white noise. There we go. So that's cool. And another thing that I've wanted to try out, which you cannot do in GeoNodes. Let me just go into the shader editor, which I'm already in. Use a principled volume node to make this actually have a shadow. There we go, we have that, and let's go and add in a light so that we can have a shadow. And turn on volume shadows. Let's go and turn up this light by a bit. The density will just be that, and the color, yeah, that'll work. I may have to multiply that by quite a bit because I really want the shadows to actually show up. There we go. There we go. So we might not even have to do ray marching, but here's the part that I actually wanted to do. Manipulating time. You may wonder, like, how will you go and manipulate time? And it's with white noise dithering. I'm going to add customizable motion blur to this. Let's go and multiply. Those of you who have watched previous streams know this trick. Let's go and set this to be a value above 1. So now we can see, let me also set this to 333.333 so that each one has a different noise phase, because if that is a singular value, that might not be the best option. But there we go. Slightly underwhelming. I think it might just be because the volume. We're in the shader editor for the entirety of this project. I forget. Alright, Eevee shadows still do not consider the world. Or they do at certain angles. Yeah, no, that's bugged. Yeah. I thought that bug was eliminated. Evidently not. Maybe I should report that? It's because the density is too high. Or is it even a bug? Yeah, no, that is a bug. That is definitely a bug. So, let's keep that going. I'm not a big fan of the color scheme, so let me go and... Separate the hue, saturation, and value. Separate color, HSV. Restrain it using a map range node. Nope. Map range, and use a combine color. Let's be HSV, and just connect U and U, even though I don't even need those other inputs. We can see that at a surface level that is occurring, yes, as intended. We'll set that to be that and that, so that we just have, oh, very, very colorful blocks. And here I could just restrain the colors to be whatever I desire, but why is it like that? Saturation? Oh, because no, I want to constrain the outputs, not the inputs. Keep forgetting that. This is like the 15th time I've accidentally done that. So what's a good hue that I can use? I am particular for the blues. The pinks are good as well. I think those blues are good. We'll need to add in more lights. While we're getting there, I'm still not entirely happy about this result. For this to work with ray marching, I would have to get an accurate distance estimator, but that will probably be a gigantic pain. Unless I collect like the scale data of everything, which is possible. But I really don't want to do that. Okay, so manipulating time is ever so slightly underwhelming. Doing that is a little bit better. My GPU is cooking quite a bit. But there are other ways to manipulate time. One of which... that is... I really want to make that into a node group. Yeah, let's just do it for organization. Node, make group. This will just be axis switch. There we go. We take in a value, output that. That's good. See, so much more space now. That's what node groups are for, aren't they? Even though I keep forgetting that. I need to use more node groups. There we go. So we have that and that, which isn't bad. Let me read the chat again. Let's see. This might be ignorant, but is recursive subdivision different than normal subdivision? A quick Google search isn't giving me the difference. No, there is a difference. Regular subdivision, well, actually, regular subdivision can be recursive. It's just the manner of the recursive nature. So when you subdivide an object, please do not crash. Actually, let me save this because I haven't done that. When you subdivide this and turn up the levels, it is recursively subdividing. It's subdividing again and again and again and again. But the rules are the same for this. It's using the Catmull-Clark method. Well, the method that I'm using is just a dumb split the face in twain. And make it so that, yeah, just split the face, or split the area, and then move it over to one side or the other. Well, this is just evenly subdividing it into 4 segments. So they're both recursively subdividing, but when I mention recursive subdivision, I usually mean this style. Technically not too accurate, but you know, it's fine. Okay. What else was I gonna do? Right, I was gonna warp this by the axis. So with this, we can separate our axis and then add it to our time value using a multiply. So with here, this will give us what we've seen before, which... no, that is not... Crap. I might have to put in another axis switcher. Or... I could cross product. And then dot product. Let's just do that. But no, that would not work either because no, I do need a dot product. Which one do I cross product? Because if the axis aligns with, no, okay, no. I am just going to subtract one value from the iteration source, and then we'll do the dot product of the position. This is not getting more annoying by the minute. Then we plug that into there. So this will be not the same axis. There we go. There we go. Now it's doing the wibbly warbly stuff. That is really annoying. My gut's telling me there's a better way to do that. But anyway. There we go. So we got you and you. Let me go and flip these around. Oh, this is bad. This is why this probably should be a node group as well. So that I can just portal the node data in and out. Actually, no, this is why we just need portals. Which portals, they don't even need, they're just an aesthetic thing. Where it's just like, oh, hide the node link and have like a dummy node that reroutes it to something else. They don't need to like actually affect the inputs and outputs. At least in like on the node tree level. They're just a visual thing. Ooh! That is not what I want, but that is cool. But yes, let's go and turn up the iterations again, so that we just have so many versions of noise, and it turns into an intelligent blob. Let's go and use a map range, set it to be smoother step, so that we can get some better noise from this. Oh, okay. That is novel. Let's go and reduce the amount right now. Let's set that to be, that one to be 5. There we go. Just want a little bit to be happening. Alright. Now the internal oh, okay. Yes, we can see that the shadows, Eevee shadows, are the bane of Eevee's existence. But yeah, that is, let me just go and turn them off, because they just don't really want to work. So we have all that, and this is basically a emissive texture at this time. But we got that, it's subdividing. I may have just realized something that could have made this a lot easier. Or no, that would require it to be split into 4 chunks, not 2. Never mind, everything's good. Ignore that. Let's see. Do you know what's in the compositor library? Is it empty? Is it full of stuff? I saw a real Blender guru combining different filters. Yeah, there's different filters. I went over them in a previous live stream. One of them, though, does not work in the viewer because of float point precision stuff. I think the viewer compositor only uses half precision. Well, I don't know what level of precision, but it's lower than the final compositor. So, it just straight up just shows black, which I've thought about making a bug report for that, but I straight up have not had the time, and I am not doing that on a weekend. Got too many things to do for that. We have that as well. So I really want to like standard ray march this. So let's see if we can. The likely answer is just no. Because the distance estimator is going to be very screwed up by the subdivision process. Whenever it is subdivided, the distance does not get updated. Unless we change that. And it would have to be on each... The scale would have to be manipulated on each axis, rather than on that, and oh my god, that would be so annoying to do. Or would it? I'm thinking right now, if I go and divide the thing either by 1 or 2, depending on the axis switcher, I could output another value, which would make that work, and then I just multiply No, I can't multiply the SDF based off that, because that is a float value instead of a vector value, not a position value. Dang, it is possible, but it would just be a massive pain in the butt. Because this requires the warped position that's not accurate to space, and also warping the distance based on that. Yeah, no, this is, I don't think that's worth it, if I'm being honest. There has to be a way. Just subdivide the space while keeping it accurate. Wait, does that mean I just treat this? I would need to store this value? Or, wait, no, not that one. This value and this value. That would be the size. Store that as another position, using our mix right here to determine which axis it's on. Just keep subdividing, setting the scale of the space. Let me go and try that. Let's save that beforehand because this will get messy, which I know we're already at level 10 mess, but here we are. Connect that to the output. So we have a result and the start value should be 1. So we have this in here, and then we plug that into there. So in theory, we don't even need a mix node, we just need a divide node. And we don't need that either. What I need is just the raw value. This is getting so bad so fast. We have that and that, which outputs into, not there, we need a vector math divide. And then plug in this value into here and that value into there. So now in theory, we have the position values. So if we go and take a look at this in our volume cube, what are we left with? A not so great result. Oh, right, because we do need to do that axis switch. Which means we just need plug in our input here. It'll be either 0 or 1, and then we just need to add 1 to every single one of these. Actually, no, we can do that beforehand as a float value to avoid a larger node. So it'll either be 1 or 2. Flip those around. That is going to the axis. Oh, this is bad. And that's outputting absolutely nothing. Here we go. Well, that looks cool enough where I'm going to keep it no matter what. Actually, let me go and copy this SDF value as a just save point. So in theory, if it should be accurate. Let me just go and put another, whoops, another reroute. It is dividing, and then that's, but yeah, no, that's just dividing the axes by that. Yep, that should be correct. Though, the problem is that these do not look like singular values. They should just be... Yeah, no, it shouldn't look like that. It should just be solid blocks of color. And they're really, really not. Oh, wait. The threshold means that one of you are just straight up wrong. Or no, wait, it should be correct. Because I have the axis going into there, so yeah, no, it is... No, it's not. No, it's not. Let me just go and have a nice value node, put it into here so that I can debug what's going on a bit easier. Set this to be 0.5. As we can see, the subdivisions are looking quite jolly right now. Now, why is that occurring? Okay. This value goes into here, which is going into... Ah, there we go. There's the problem. Bingo. Issue found and solved. Those look like solid colors to me. Now if we do this, they will no longer be solid. Oh, but that is a very unique looking texture. Let's go and save this in its current state. There we go. This is getting so horrifically bad in terms of node spaghetti. I'll do a pass on the cleanliness of... This is horrific. God. This is really bad. I just got a message by one of my coworkers from Sonic 3. Hey Ben, I'm watching. Give me a shout out. So to Gavin Wellen, here's your shout out. I'll see you next week. But yes, that was funny. But yes, yeah, let's go and add in a little organization pass to this because this is getting very out of hand. So, node, make group. When in doubt, node, make group. And let's actually label these because, as we can see, there's your problem. There's your problem. And I could, wait a minute. Ungroup because I did not put everything that needed to be in there. Put a reroute in there. So the goal, okay, cleanliness pass, this will, oh, we're at an hour. Oh wait, no, dang it. Let's go and select all this and all that. Node, make a group and eliminate that one. Node, make a group. Oh, it's back to Control Z. I thought they got rid of the hotkey for that. Though I am famous for being mistaken about those things. So the input, there's input and then the vector. So we have position. Okay, no, okay, let's reorder this. So iteration input is the position, which, yeah, position. Result should be the position. Or in this case, the UV. Just position, that's fine. Seed, that should be the seed value, which should be an input and an output. And then the vector should be scale, input and an output. There we go. So now I need to close my blinds real quick. That was blinding me. Okay, there we go. Organization. I should not have let it get nearly this bad. This is really, really bad. Okay. So at least these parts are mostly okay. The seed value, we can plug in, oh yes, portals. We make node groups so that we can have portals because we don't really have them just yet. So there is still some node spaghetti going around, which can we fix it or no? I have a feeling no to an extent. Because we still need all that to occur. That is annoying me greatly. So it would just be that. Oh wait, no, that's not too bad. Okay. So the seed value is just like that. That's fine. The divide. Like that. That's fine. That is fine. That is fine. That is fine. That is fine. That's not fine. go and split those up. There we go. Organization is almost complete. We can go and portal in the position over to here so that we can also have... Ooh. Oh, come on, buddy. And then we have you, which goes to there and over to there, which is a little bit unavoidable. But at the very least, it is somewhat better, although I can just go and bring you over to there. And that over to there, bring that over to there, move you all over to here, take the seed value, put this all into a nice little frame, put you over to here, that there. Not terrible. GF, put that over to there, put that up here, move that over to there. Not bad at all. Now the noise is put over to there. So, for a cleanliness pass, not the worst. Still not 100% ideal. But not bad. Okay, yep, that is good. Let's go and take a look at the output. Not bad. This will just be subdivide axis. Correct the misspelling. There we go. That's not bad. And we could just go, yeah, no, not bad. Concrete flow of data. There we are. Not bad. Could be better, but yeah, not bad. And also I could add in a vector math and keep that at 0 or that value, but it's fine. Completely fine. Vector result. Yeah, no, that's... Oh my gosh, I forgot how messy this part was. I keep jump scaring myself with node setups. Okay. Disconnect that, put this over to here. So, now that we have our scale value, which is accurate now, I should be able to... Oh, no, wait, I also need the position value as well. Wait, no, is the scale also the position? Now we're dividing that. No? Oh, wait a minute. Wait a second. No, I would need the scale. Scale value is needed, but I would need to have another pass going through. That would add scale at each part again and again and again. Not... Okay, this is going to be really... Okay, I think this part is somewhat unachievable again. Because if we go and connect the scale to our color, take a look at this, that's just the scale. But if we take our position input and multiply it by said scale, we do not get a good result. Because it's not centered? Wait a minute. Maybe it is. Well, one way to find out. Would you look at that? Wait a minute. Ah. Although, wait. Nope, I think I did absolutely nothing here. Or not entirely nothing. Subtract. No, I need a... What would be the right way to get the location of each and every cell? It wouldn't just be one value because I'm inputting the axis, which I should remove. So we should see no stretching of said checker texture. Or actually, wait. Here. Nope, that wouldn't work either. Let's go and multiply by the scale. Now it's not stretching. No, it is still. Okay, no. Bad idea. There is a way to do it, I'm just forgetting. Or wait. Take the scale. I can take the position of each cell. No, that would be each middle cell. Or would it? I divide both of those by 2. No, okay. Well, I think it may be time to call this part a wrap. No, it still feels plausible. If I take just these values and then output them, depending on the axes, it would just give the position, but then I would need to scale each one recursively with all that. With the previous scale. So I would need the scale. But I would need to... We might need another value. Okay, well, we're in too deep now. So let's just, Actually, wait a minute. Let me go with my original plan, which was to have this as 0 or 1 or whatever it is, and just vector math add so that we do not need a redundant node for this part. So that is our scale value right there. And then this is our position value in space. So now we just need to add again and again and again to our position to get our cell value location. Right there, that should be that. And then here, we just need to have a new input. So let's go and get an add node. Plug this into here. So there we go. We have that and that. Plug that into the repeat zone. So in theory, once again, plug some more data into the output. And we just get white. Alright, what is... Should be location for the cell. Location and location. So you right here should be fine. We just have that, goes into there, add. So it should be... And right, it's going to be the middle of the cell, not the actual proportion. So each one of these will be in the center, which is not great. Oh, and wait, I almost forgot. Wait. No, we need to multiply that by the scale. That's why the value was so high. So if we do all this, this is horrifically complicated. Doing this in geometry notes would have been so much faster. And then that would be a multiply by the scale. Plug that into there and it should work. So. What is your issue currently? Plug you into you. Plug you into you. What is your problem? That's just a mission, so let's go and plug that into our color. The value is way too high. And not correct. That part should be high. Closer it is to there, it should be almost 1. But we're not getting that. It's because it's still trying to get the cell center. Like it seems like here, actually, wait, let me go and separate the axis. Actually, no, we're going to just multiply so that I can see the axis a bit better. That is incorrect. Let's take a look at the R. Or the G. The y-axis. That is massively incorrect. And the Z, massively incorrect. Okay. What is your problem? We have just those values, which are doing their job. We have the mix, which should be doing its job. That gives us the middle. Oh, wait a minute, it's not. That's the middle. But it's still incorrect. Okay. And it wouldn't give me the middle of each cell because we're not, dividing and all that fun stuff. Oh, wait a minute. We have that as well. Okay. Not fun at all. So here, I just need to, I think, oh wait, and you just need to be a multiply. Why am I tripping here? You just need to be a multiply. Come to think of it, nope, that's fine. That one does need to be a mixed node, okay. Plug you into there and that into there. Nope, not into there. That into there. Delete you because the value is again just 1. That into there. Plug you into there. And with all that considered, let's see how wrong it is. Reroute into there. Take a look. No pattern discerned. No pattern discerned. Okay, I'm going to spend 5 more minutes on this, and if I cannot figure it out, I'm just going to put it to rest for a bit. Though. It's all right. And that should be, nope. Values should be filtered to where they are in space. Let me go and turn, let's go and remove you. Just to double check. Nope, okay, incorrect. Delete. Take a look at you. Reduce you to be 1 iteration. That is a problem. Result, which is, let me go and rename the parts here. This should be scale, caps lock scale, and this should be location. There we go. Let's take a look at this internally. Scale, at the very least, should be okay. Let's go and take a look, make sure all that's good. Yep. Let's just go and do that so that all the lines are nice and organized, even if they are a bit big. Let's go and plug you into there. Make sure you are occurring as intended. Use a multiply node so that we can see what's going on. Okay, that should be 1, that should be 1, and that one should be manipulating. Uh-oh. I think I found our issue. The issue is that the larger cell is becoming smaller. Or the scale of it and all that. We do a multiply. Indiscernible. I think these need to be flipped around. Bum, bum, bum. Restored. Could have used a 1-, but not gonna worry about that. Let's put another reroute over here so that I can... Oh, God. Yep, nope, this is becoming bad. Okay. Let's go and check that with more subdivisions, and we can see, yep, the scale. Okay, the scale's actually working this time around. Let's go and take a look. Just debug the absolute living hell out of this. That looks cool. Okay. Oh, it is not liking it when I zoom in. Okay, let's go and save this in its current state, because it's actually somewhat working. Take a look at the location, which in this... not occurring correctly. Or is it? Oh, wait. Oh? Wait a minute, let's go back to square one. Okay, it is putting the midpoints in the correct place. But... it's not putting in the actual midpoint. Or not in the cell center. So, I think all I need to do to make this work is use another gosh darn mix. Actually, no, not the worst thing in the world. I just need to mix between 0 and 1, which we already have. I think that might have just worked. Maybe not. Let's go and check. Huh? Wait a minute. Wait a gosh darn second. Let's go and check the... Nope. Okay. It seems like it is still scaling up over time, but we can see it's... Oh no, that's why. It's not mixing to the previous scales, minimum and maximum. It's yeah, no, that makes sense. Okay, so this value, instead of being just 0 to 1, it needs to... Come on, work brain. It needs to be the minimum and maximum bounds of the cell. Meaning that I would need to access the location and scale of the previous cell. I would need to access the minimum and maximum of each cell. That sucks. Big time. Okay, how else can I make this work? If I access the previous scale, then I can offset the center by that value. And then get the next portion. Oh, wait, that could work. It would be so that the location is at the center corner of each one, which is fine. That may indeed work, and I would have to dot product the axis of the scale in order to offset it the correct amount. Actually, no, wait, this is being scaled. Okay, yeah, no, this is becoming a little too much for me to handle, so, okay. I'm going to eliminate this section. Close to working, but it just overwhelms me. But we did fix the scale part, which I think we can indeed keep. So let's just go and take out you. So, keeping it simple, we're almost at 1 hour and 30 minutes, which is too long to spend on simple 3D recursive subdivision in a shader. 2D is so much simpler. But yes, we have all that. That is fine. That is good. We have Yeah, the local UVs. We have that. It's cool. Even if it did not fully work, it is cool to see. Yeah. How about that? What else should occur? I could also switch this around. So that... Wait a minute. That one should be... Yeah, let's use a greater than here instead. And then we can go and do... Come on. Oh wait, no, that's the wrong value. Well, that should not happen. It should be a greater than. So I should get the inverse of what I just saw. Go and do... Whoa, wait, what the heck? I screwed something up. Okay, back to it actually working. Needs to be like that. And then simply switch that to a greater than. What the hell? Yeah, no. We round those out and then we just get the opposite of what we're currently seeing. The point. Oh, wait, no, I know what's going on. Yeah, no, I would have to clamp this by the bounds. So basically, I would have to do an, we do not have a vector compare, do we? No, we do not. I would have to do each axis separately. Unless I had a very handy cube setup to multiply against this. So what I'm just going to do is do this, have a nice unsmoothened cube, just use a nice less than node. So if that is occurring, we can just go and do this. Plug this into you and you, plug you into there. So now if this is a greater than instead of a less than, we should see that that happens. Although that is not what should happen. Let me go and zero that. Ah! Wait, what? Oh, because, right, this is centered. So now we have cubes doing this. Not the most interesting result, but pretty cool. You know, I am thinking that the GeoNodes version might be better. Okay, and then we have that. Yeah, maybe this is very much a GeoNodes kind of thing. Let me go and reconnect the part that makes this special. That we can warp all this in space. Once again, we're distorting time. We can actually see it all warping, which is cool to see. If I were to switch this to cycles, nope, it would absolutely hate me because we are using repeat zones, which are not accelerated in cycles. Okay, steps we can turn down. Nope, don't want to do that. Down that because these are dithered, max depth. Not sure what that does. Alright. So we have that, we have that, we have that. Let me go and turn off most of this so that we can keep the simple method. Change this to be a less than once more. So now we have very nice rounded cubes. Let's go and reduce it even more. Yay. You love to see it. And the color is indeed the scale. Let me go and multiply the position by the scale value to get just a value. As we can see. Wait a minute, no. I already have the accurate scale value. No, that's what, no, I needed the location value. That was the problem. Right. Man, shaders are very difficult to wrap my brain around. Yeah. It's like the inverse of the geometry node problem. Or, no. Well, kind of. Because data, if you store like a position value or like a point in space and then move it, it works. But in the shader, everything is just in the ether. Okay. So, I think that's good. Though I want this to be a little bit more extreme. So let me go and set this to be that and that. Why does it seem heavily biased towards... Oh, wait, no, this needs to be 0.999 and 0.110001 so that we don't get any float point precision issues with dividing by 0, essentially. So now these will be much more chaotic while never actually going kaput. So we have all that. It's good. Let's go and warp it even more so that we get a very nice jello, which you can't even discern this as recursive subdivision at this point. Which is a little unfortunate. But it is a cool shader. I guess technically it is still being ray-marched because I think EV volumes are ray-marched. I would assume. Dithered ray-marching. Oh. I should try that. But yeah, we have all that. Very cool to see. And then shadows, just don't really work. We can turn down just the regular shadows in case I add in anything. But we can put in a nice mesh plane and we can see eclipse just fine. So it's using depth. Cool. Again, we just have that. We have that. We have that. Subdivide. Yeah. We're not subdividing each quadrant, we're subdividing it in half each time. So kind of like a BVH. Wait, BVH is dividing it twice, if I remember correctly. Yeah, that is that. I do not know where to take this process further. Let's make these not rounded cubes, just regular old cubes. Being warped and all that fun stuff. But what other time dilation effects can we do? Because we still have this, which just turns into muck after a certain point in time. I'm happy I made this, though. It is more complex shader. It is much easier to do this in geometry nodes. But I'm glad it actually worked. It's all good. Let's see. Alright, what should I end the stream on? Probably some other ray-marched stuff I'm working on, though I haven't been able to do too much. I wish the actual ray-marching worked with this. Because... No, I just can't get a good distance estimate from this. But can I get a good position from it? Because I'm seeing the position right now. Actually, wait, how does... If the volumes are ray-marched, which I'm still not sure if they are, I haven't looked into that. Actually, wait a minute. Volumetric effects. VRAM, volumetric samples, distribution... Depth. Not seeing anything about ray-marching in there. Okay. They would need the distance estimator, which how would they get that? How would they get that? Not sure. Add is fine, and all that's fine. Okay. That's cool, but standard. Again, let's plug in the scale to it, which I think that looks pretty cool. I can scale the distance, but that would not be... Or would it be? No, because I would have to scale each axis. Though I could just... Wait a minute. Oh, Raymarch cube. It's gonna hide that one. Let's go into you. So we have you and the scale, which is that. But how would this work? The way I'm thinking in my brain. Just multiply that by that and then just get the length. And then, yeah, no, we subtract 0.5 and then do the scale. Then we can use a subtract. We can output this, plug this into our distance. And absolutely nothing occur. Wait a minute. It's a bit bad. Divide. Nope. You can see just how warped it all is. And right, the position is warped, of course, because of that. I mean, it almost did something. It's scaling the space, which leads to a cool result, but not a good one. Because, yeah, no, the scaling the space from 0 when this does not actually scale from 0. But if I were to... Forget, does this start from 0, 0? Oh, wait, yeah, no, and this is just the length. So if I set this to be distance from 5, not accurate, but cool. And subtract. No, that would be... Dang. It almost works, but not quite. When it goes to the negatives, that is also very, very funny. And if we make it just even less, it kind of just disappears on us. Alright, well, that's good enough for now. Oh, we are almost at 1 hour 40. This is way too much time spent on a funny little experiment, which, well, led to some cool stuff. It was not accurate. So, let's just go and hide. Hide you and airplane. Alright, well, I guess that's it for today. Let me go and exaggerate the, stuff. here again. Not bad. Just needs more samples and it'll be good. It's a shame that the shadows are not accurate. But yeah, it's okay. Then setting that to be like 0.25. I still want it to read as a square, but a rounded square. Yeah, that's fine. And then I can still go and use the other hue. Not a big fan of those hues whatsoever. I like those hues. But I think the scale looked the best. Let's also take a look at... Oh yeah, no, that's cool. Just seeing the moving around UV maps, probably a pain for compression. Actually, oh no, I should have been in standard. A little bit better, but the hues here are not quite good. Let's do HSV, bump that up by a bit. Just try to make it a little bit more appeal. Oh yeah, no, that's better. Yeah, there we go. Maybe lower the background. Oh yes, just assault your eyes with color. Yeah, no, that's good. Alright everyone, thank you all for watching this little experiment. While it technically was successful, it wasn't as successful as I thought it would be. Or, no, I knew getting the position would be a pain, though I tried it anyway. Alright, thank you all for watching. I hope you all enjoyed. If you end up recreating this, which I do not expect anyone to do, because this was, it's a bit of a mess. But if you do, more power to you. I hope, it works out. Thank you all for watching, and I will see you next time. Have a good one.